Hello. In this video, we will prove that the derivative of arcsine x, also known as sine inverse x, is equal to 1 over the square root of 1 minus x squared. Now, to start this proof, we're going to need a bit of a trick. We're going to need to write sine inverse of x equal to y. We don't know what y is, but the extra variable will help us in our proof. And so, now since we know that sine inverse of x equals y, we can take sine of both sides, or equivalently using the definition of inverse, to state that x is going to be sine of y. The reason we do this is because we don't know the derivative of sine inverse. That's what we're trying to determine. But we do know the derivative of sine of y. Sine of any variable, in fact. And so now, if we differentiate with respect to x, we get the following. d dx of x equals d dx sine y. Now the left-hand side, the derivative of x with respect to x, is simply 1. And on the right-hand side, the derivative of sine y is cos y times the derivative of y with respect to x. That's using implicit differentiation or chain rule. So now we actually have here dy dx. Since y represents sine inverse, this term right here is representing the derivative of sine inverse. All we need to do is to isolate for this term, and we'll be done. So what we want to do is divide both sides by cos y, and we get dy dx equals secant y. There's just a problem here. We don't know what secant y is. So what we need to do is go back to our original equation where we set up y and we set up x. And this equation will give us some more information. It says that sine of y is equal to x, or equivalently we could write x over 1. Now that means we can construct a small triangle. Imagining y to be the angle, we know sine is opposite over hypotenuse. So we now have opposite and hypotenuse. To solve for the missing side, we can use Pythagoras, and you can check that it will be the square root of 1 minus x squared. Now, using this triangle, we can very easily see that secant of y, which is 1 over cos y, which means it will be hypotenuse over adjacent. Secant y will actually be equal to 1 over the square root of 1 minus x squared. And so substituting that back into our equation, we have dy dx is equal to 1 over the square root of 1 minus x squared. And of course, that is equal to the derivative of arc sine x. So again, to recap in the proof, the first thing we do is write down sine inverse equals to y. And we take sine of both sides to get it into terms of a derivative we know. Once it's in a derivative we know, we can differentiate both sides with respect to x. We end up isolating for dy dx to get secant y. We don't know what secant y is, but this relation here gives us a triangle. Using Pythagoras, we can solve the triangle for the missing side, and find that secant y is 1 over the square root of 1 minus x squared, finally giving us the derivative of arcsine x. Thanks for watching.